I'm going to talk a little bit about solving both linear and nonlinear systems of equations. Two ways to do that, two really good ways to do that, are by the method of substitution and graphing. Substitution is a great algebraic method. The one thing that's required for substitution is that we want one of our two equations solved for one of our variables. So looking at this system over here at the left, a really good example of this would be the fact that that top equation would be pretty easy to solve for x. It's all by itself right here. All we need to do is get rid of that 4y. So the first thing I'm going to do is take my equation, and I'm going to go ahead and say that x would be equal to, let's subtract 4y over to the other side. And now that I know what x is equal to, I can go into my next equation, right? That would have been 3 times x minus 2y equals 9. But instead of x, I'm going to plug in what I know x was equal to. X was equal, according to our top equation, to 10 minus 4y. Now we have an equation that really only has y variables in it. So therefore, now let's just do a little bit of algebra here. I'm going to distribute my 3. So this becomes 30 minus 12y, still minus 2y, and still equal to 9. I'm going to combine a couple like terms there. So again, I've got negative 14y. And while I'm at it, let's go ahead and subtract our 30, right, over the other side. So that's going to become a negative 21. Dividing by negative 14, I'm going to get a positive 3/2, or 1.5. Now, don't stop there, because remember, we want to solve for both x and y. The solution to a system of equations, such as shown in the graphing problem over here at the right, is the point where two lines cross. And so we need to find both the y and the x. We need the entire coordinate where those two lines would cross. So let's go ahead and plug our number back in. And this is a great time to go ahead and use that purple equation we had up top. X, remember, was equal to 10 minus 4 times y. And if we plug in the fact that we know y is 1.5 now, or 3/2, 10 minus, again, 3/2 of 4 would be 6, and x equals 4. Now, we can quickly go back and check our answer by just plugging our numbers back in. We could also solve both equations for y and do this problem by graphing. But again, we'll talk a little bit more about graphing here in a minute. So again, a great way to go about this, though, is to go ahead and check our answer. And I'm going to do so down at the bottom. Now, your teacher may or may not require you to do this. Most of the time, I'll just do this problem or do this portion, on my calculator. But again, we could simply say 4 plus 4 times 1.5. And do I get 10 back? Well, again, that's 4 plus 6, which definitely comes out to 10. And then we would want to check it in the second equation. 3 times 4 plus 4 times 1.5 again. And again, 12 plus 6 is going to be, and that was not the right equation, so that's a problem there. Make sure we're looking at the right place, huh? 3 times 4 minus 2 times 1.5. And we want to know, is that equal to 9? Well, again, 12 minus 3, and 9 equals 9. Again, also checks. We'd always want to finish, right, our statements there. Make sure that we have no argument with the fact that 10 equals 10, 9 equals 9. We know that's the right answer. And that's what I would do over here at the right. Again, the first thing I would probably want to do is solve both of my equations for y. A quick and easy way to do that, just subtract your 2x. Negative 6y equals negative 2x minus 14. And then divide both sides. Right? Make sure that whole side is divided by negative 6. Now you can simplify that down if you want to, but your calculator will handle it just fine. Same thing goes here. Y equals 1 minus x, and we'd have our equation to graph right there. Now we can see that on our graph on our screen, though, it looks to be about negative 1, 2. And again, we could take those numbers and we could plug them back into our equations and make sure they work. Obviously, in that first or that second equation, negative 1 plus 2 is positive 1. I would say it's going to work in there. And again, we could check it out. 2 times negative 1 minus 6 times 2. Again, we're going to get negative 2 minus 12. is negative 14, which is exactly what we wanted here. So again, we get a good answer of negative 1, 2. Make sure you can clearly identify your answer, even if you show the check on your page. We want to know that we are looking for that coordinate point where those two lines cross. Let's take a look at a couple other problems here. What about for a nonlinear system? Again, graphing is a great way to go about that, but you can solve a nonlinear system via substitution. Again, if I'm looking at my equation up here, I definitely noticed that in my two equations, I've got a negative y in both of them. So what I'm actually going to do is take my first equation, and I'm going to go ahead and just substitute in my second one. I'm going to take that negative y equals negative 2x minus 1. I'm going to run a negative through there, so y equals 2x plus 1. All right, I'm just going to multiply both sides by negative 1. And what that means is x squared from the top equation plus 4x minus y, 2x plus 1, is equal to 7. Well, that means x squared plus 4x minus 2x minus 1 equals 7. And we get a simple quadratic equation, which might be tempting to move our 1 to the other side. But again, I would actually probably bring that minus 8, bring that 7 over to this side. Much easier to solve a quadratic equation if you're equal to 0. Right? Two things that would multiply to 8 and add to negative 2. Well, I'm thinking x plus 4, x minus 2. And that just tells me that more than likely, right, we've solved quadratics before, we're going to have two possible answers here. So we're going to have to solve this thing twice. Now I'm going to go back to my blue equation right here, right, that I had found earlier for what y was equal to. And let's go ahead and plug our numbers in. If x equals, right, negative 4, then y equals 2 times negative 4 plus 1, or basically y equals negative 7. On the other hand, if x equaled 2, well, then we got to say that y would have equaled 2 times 2 plus 1, and y would have equaled 5. And it just so happens we get two answers then, that at x being negative 4, right, we got negative 7, or at 2, we got 5. And we're going to get two possible solutions. Now, why would that happen? Well, realize that's a quadratic equation. Again, we've got that x squared going there, so we're thinking that's a parabola. And a straight line can definitely cross a parabola in two places. Kind of like over here at the right, we've got these two equations here. And you'll notice that one of them makes a circle. We're familiar with the circle equation. X squared plus y squared equals 9. Again, as a circle of radius 3. Now, to get that to graph on our calculator, again, we're going to have to solve for y. So I would say y squared equals 9 minus x squared. And then we would have to take a square root. And don't forget that anytime we take the square root of both sides, we've got to say plus or minus. So if we hop onto our calculator then, right, we can graph those. So I've got the positive square root of 9 minus x squared. Now notice I didn't put in the negative square root. So let's go ahead and put that in. You can either type the entire thing, right, negative the square root of 9 minus x squared, or because this is all entered into y1 right now, realize there is a nice shortcut. If you go to your variables on your calculator, we want a y variable, and we deal with functions. And again, that's why we need two functions to begin with, is that plus or minus the square root of is not going to be a function. It wouldn't pass a vertical line test, right? A circle wouldn't pass a vertical line test. But if we pick y1, we're going to take everything from y1 here and put it right down here. So now it's negative the square root of 9 minus x squared. Again, we can hop back over to our graph and notice now we get the bottom half of our circle. Now you'll notice we got a slight problem on our circle. It's not connecting there, but it shouldn't be an issue for us on this top right portion. We can say second, calculate the intersection point. Okay? And we've got our blue line. And now we are on our logarithm, we're on our red line. So we're going to need to press up or down, and we're going to get ourselves to this black line, right? Because we want to know where those two lines, the blue and the black, cross. So it looks like 2.816. Right, this point here is going to be 2.816, comma, and then if we hop back to our calculator, 1.035. 1.035. So there's one of our points. And now to get the other point, we need where this red line crosses the blue line. Well, you'll notice on that one, we can't really see the black line right down here. We can't see our logarithm with that red line. Now we know it drops down. Our logarithms have a vertical asymptote, and we know that. But if we take our window and we kind of shorten up the y values, we're just too wide right now. Let's go ahead and say, how about negative 0.5 to about 0.5, and see if that doesn't make that black line, right, drop down a little bit lower. Oops, wasn't the y values we wanted to change though, was it? I want negative 0.5 on the x's. I needed to narrow my screen. But again, from negative 5 to 5 in the y direction, that point seemed to be showing up previously. There's our circle, right? This was the top and bottom of our circle. We've just narrowed in so much that it looks very flat. But now notice I can see that intersection point. So second, calculate the intersection, number 5. Right? Again, I don't want to be on the blue line anymore. I want to be on the red line. And our second curve, right, we need to get onto that black line. So it looks like there we are. Now we're on our logarithm here. So we can press enter, and we should get an intersection 0.0498. So 0.050, it looks like. Comma. And if we go back to our calculator one more time, negative 0.2999587. Now I know that's not really negative 3. It's not right on the button of negative 3, but again, accurate to 3 decimal places, that would be. So I'm going to go ahead and say, actually, let's just go ahead and keep some extra decimals. 2.9996. Never a bad idea to be a little more precise. 3 9s and a 6, just to show us that we weren't exactly negative 3. Again, that's a great way to solve by algebraic method, substitution, or solving graphically. I hope that helps you solving equations. Good luck, and if you have any questions, talk to your teacher. Have a great day.